Hello everyone. In one of the previous videos, I made an Arduino Nano-based oscillator to test the oscilloscope. The signal frequency in this generator reaches 8 MHz. It was not possible to check the generator at the maximum frequency then, because the oscilloscope did not have very high characteristics. But today I want to test this Arduino Nano-based oscillator using a modern 2-channel Gochifix oscilloscope. The bandwidth in this oscilloscope is 80 MHz, and in general it has very good characteristics, which I will tell you about now. But first of all, I want to inform you that a 25% discount is available for every viewer of my channel when buying this device. To get a discount, just go to the manufacturer's official store via the link that will be in the description under this video, and enter the promo code that you see on the screen, and it will also be in the description under the video. Well, now let's take a closer look at what kind of device it is and then proceed to testing. The Gochifix multimeter is sold in such a box, which shows the type of device and also indicates its main features. On the back of the box are the main characteristics of the device. And here is the multimeter package. First, let's pay attention to the device parameters specified in the instructions. The user manual is in English and it is very detailed. About half of the instructions are devoted to working with an oscilloscope, and then we are talking about a multimeter. The general characteristics of the device are indicated here. On the next page, the characteristics of the oscilloscope. The bandwidth is 80 MHz. The sampling rate is 200 megasamples per second. These are very good, high indicators. The oscilloscope is dual channel, which is also a huge plus. Entrance, open, closed and ground. Vertical sweep from 10 mV to 10 volts per division. Horizontal scan from 5 nanoseconds to 50 seconds per division. Trigger operation mode, automatic, normal and single. The type of trigger on the rising edge and on the falling edge. There is also an automatic oscilloscope setting. The oscilloscope measures the signal voltage from peak to peak, the maximum and minimum voltage, the average voltage of the signal over the first period and the RMS voltage of the signal, that is, the true effective voltage of the signal. The following are the characteristics of the generator. The frequency of the sinusoidal signal is from 1 Hz to 5 MHz, a rectangular signal from 10 Hz to 1 MHz. The triangular signal has exactly the same frequency. Next page, characteristics of the multimeter. Measurement of constant voltage up to 1000 volts. Measurement of AC voltage up to 750 volts. This multimeter also has a true RMS function, that is, it measures high-frequency voltage. Next, the measurement of direct and alternating current up to 10 amperes. Resistance measurement up to 60 megohms. The capacity is up to 100 millifarads, that is, up to 100,000 microfarads. Frequency measurement up to 10 MHz. The multimeter also has standard functions for checking diodes, checking the electrical circuit and an audible signal. Next, it is indicated what all the symbols on the device screen mean. Well, judging by the characteristics indicated in the instructions, the Gochifix multimeter is a wonderful measuring device. I was especially pleased with the oscilloscope, which has very high parameters. There are several probes included with this multimeter. Multimeter probes. The wire is soft and long enough. The measurement limit of these probes is 1000 volts and 10 amperes. The generator probe. Here is the BNC connector. The oscilloscope probe. There is also a BNC connector. There is a calibration screw. A calibration screwdriver and marking rings are attached to this probe. And a USB Type-C cord for charging the device. The multimeter is quite large, but thanks to this it looks impressive and solid. Black and orange colors go very well together. On the side there is a connector for connecting a USB cord. There is also a stand. There are 3 BNC connectors in the upper part, 2 oscilloscope inputs and an oscillator output. The diagonal of this screen is 2.8 inches. There are function buttons under the screen. Then the oscilloscope control buttons. Menu buttons, enable and disable, save data. There are 4 probe connectors at the bottom. At this stage, I really like the device. It has a nice appearance and excellent characteristics. And now I will check this device in operation. First of all, I will test the oscilloscope. Now I'll connect the generator and let's see what the waveform will be. By default, the device is loaded in multimeter mode. To turn on the oscilloscope, press the CH1 or CH2 button. Using the control buttons, you can edit the system settings, as well as the display of the waveform. The first button is the system settings. To edit the selected item, press the Enter button, and then use the arrows to select the desired value. The first point is to turn on and off the audio signal. The next item is the brightness of the screen. The third point is the auto-off setting. The next button is the trigger setting. Now you can use the function buttons to select and change the appropriate parameter. F1 is the channel selection. Next, the type of launch on an ascending or descending front. Trigger mode, single, normal and automatic. F4 is the reset of the trigger level to the middle line, that is, to 0. A few more buttons are located just below. This button is a functional menu. The first point is to set up the waveform. Each channel of the oscilloscope is configured separately and independently of each other. Now several menu items open. The F1 button is the type of entry, open, closed or ground. Next is the divider. The F3 button enables and disables the 20 MHz bandwidth limit. F4 is the next page. The F2 button enables and disables horizontal and vertical adjustment of the trigger position. The next item allows you to select which input voltage data will be displayed on the screen. For example, peak-to-peak voltage, maximum, minimum, and weather RMS. Now the selected values are displayed here on the screen. The next item allows you to display some more data about the incoming signal, for example, frequency or period. The next item is inverting, then the cursor, that is, the device allows you to set 2 points on the oscilloscope and then calculates the difference in voltage or time. And the last point is calibration. The next button is the automatic setting of the waveform. Then the save button. The device can record in its memory a screenshot with an oscillogram or with the measurement results. Up to 200 waveform images can be stored in the device's memory. The last button is to start and stop the waveform. When the waveform is stopped, the message stop appears on the screen. Well, the control of the oscilloscope is simple and you can quickly get used to it. Now let's compare the readings of the oscillator and the oscilloscope. A rectangular signal with a frequency of 1 kHz and a peak-to-peak voltage of 3 volts. The oscilloscope shows exactly the same values. The signal frequency is 5 kHz. The oscilloscope has a frequency of 5 kHz. The signal is rectangular. 10 kHz. The signal is a bit overwhelmed, but this problem is not in the oscilloscope but in the generator. That's why I built an Arduino Nano-based generator. Theoretically, it is capable of producing a rectangular signal with a frequency of up to 8 MHz. Now, with the help of this Gochifix oscilloscope, I will check if this is really the case. The frequency is 10 kHz. The signal is clearly rectangular in shape. (100 kHz). The frequency is 1 MHz. The signal is rectangular. The signal frequency is 8 MHz. This is the maximum frequency that an Arduino Nano-based generator can produce. As you can see, the signal on the screen is quite rectangular. So, the generator, assembled on the basis of the Arduino Nano, outputs a signal with a frequency of 8 MHz. Of course, the signal is slightly distorted and noisy, but nevertheless, the circuit is working. The sinusoidal signal is 10 kHz. The frequency is 50 kHz. The oscilloscope has exactly the same indicators. The voltage from peak to peak is 3 volts. And the maximum frequency that this generator is capable of is 100 kHz. The oscilloscope shows exactly the same frequency. A triangular signal. The frequency is 50 kHz. The oscilloscope also shows a frequency of 50 kHz. The voltage is slightly lowered, 2.8 volts, but most likely the problem is not in the oscilloscope but in the generator. As I said, the Gochifix oscilloscope is dual channel. I connected the second probe, and now let's see how two waveforms are displayed at the same time. So, the oscilloscope in this device has very good parameters. The measurement, that is, the construction of an oscillogram, is fast and accurate. Also an important factor is convenient operation. Now I'm going to check how this device works in generator mode. To turn on the generator, you need to press this button. I will check the shape of the signal using this oscilloscope. So, a rectangular signal with a frequency of 1 kHz. The frequency is 100 kHz. There is a rectangular signal on the oscilloscope. The signal still resembles a rectangular one, but the corners are already filled up. The sinusoidal signal has a frequency of 5 MHz. The waveform is shaking, but it can be easily disassembled. And it remains only to check this device in multimeter mode. The first button enables the measurement mode of DC and AC voltage, frequency and duty cycle. A finger battery. Its voltage is 1.39 volts. Using the auto button, you can switch between manual and automatic measurement mode. The stop-start button captures the measurement result on the screen. To measure the AC voltage, press the F2 button. The mains voltage is 238 volts. Using the F3 button, you can measure the frequency. The frequency is 50 Hz. The next button turns on the mode for measuring resistance, capacitors, as well as checking diodes and electrical circuits. The resistance is at 10 ohms. The device shows exactly 10 ohms. Another resistance at 820 kiloohms. The result is 829 kiloohms on the screen. Checking the diodes. Next, check the electrical circuit and beep. Checking the capacity. A 10 nanofarad capacitor. Precisely. Electrolytic capacitor for 2200 microfarads. Almost 2000 microfarads. It took about 5 seconds for this device to measure such a capacity. The next button switches the device to the current measurement mode. The first two buttons are the measurement of small currents, but the next two are the measurement of large currents up to 10 amperes. The device tells you which connectors to connect the probes to. Now, I am measuring the current strength of this LED strip. The current is 247 milliamps. Another LED strip. The current here is 400 milliamps. To summarize, it is safe to say that the Gochifix multimeter and oscilloscope is a convenient, reliable and accurate measuring device. In its category, including in price, it is probably one of the best. This concludes this video. If you liked it, then click the subscribe button so that you don't miss the new video on my channel, which will appear very soon. I thank you for watching and see you soon.